Okay, so yesterday we learned to solve triangles when we were given side, angle, side by switching to the law of cosines. So hopefully that's fresh in your mind here. Um, and so we have learned to use the law of sines when we were given angle, angle, side, angle, or side, angle. And then we learned to use the law of cosines when we had side, angle, side. Because when you have to switch to the law of cosines if you don't have a pair of values like angle A inside A or angle B inside B and angle C inside C. You have to have a set of pairs to use the law of sines. Well, with the law of cosines, you get side, angle, side. You don't have any pairs, and if you get side, side, like we're going to work with today, you just have the sides and you don't have any of the angles, so you can't use the law of sines. So our objective today is to be really smart, use the modified law of cosines. Modified, I'll explain in a minute, to find a missing angle. Then you'll solve the triangle completely and you get to choose your choice of formula, whether you want to switch to the law of sines because now you'll have a pair of opposites like side A and angle A, etc. And then on the last step, if you want to switch to angle sum theorem, and you can do that because when you give in side, all you're looking for is angle, angle, angle. You know what I mean? And now that I said that, angle, 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 let me just remind you that in order to solve a triangle, you have to have three pieces of information, and one of those pieces of information has to be a side. It has to be. Like if I were to give you angle, 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 let me just say this is a 60, 60, 60 right equilateral triangle. Well, I don't know if this is 2, 2, and 2, or 2000, 20, 20, 20, 2000, 2000. I don't know what size the triangle is, so I can't solve it. So remember that. That's important for 11.2c, that when you're given angle, 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 you can't solve the triangle. Okay, you have to have a side in order to solve a triangle. Okay, so let's remember the law of sines. Here it is. The law of cosines. All right, so you're given a triangle like, say, ABC. That's a really beautiful triangle there. So here's triangle ABC, and this will be side A, side B, and side C. Okay, so yesterday we learned how to solve these if we were given side, angle, side. So let's say that I was given A, B, and angle C. That's definitely side, angle, side. So the formula, so then what I would want to do at this point would find the opposite of angle C, side C, so that I could maybe switch to the law of sines if I want to. I could stay with the law of cosines if I want. Yes, but I'd have to switch to finding angles. Anyway, so the law of cosines, if we were looking for side C, you could say C. So let me do that again. I'm not sure why I erased the whole thing. C squared equals A squared plus B squared minus 2AB cosine of C. Okay, and of course, if we were to switch that information around and say we had instead side C and side A and angle B, then of course we would be looking for B. And so we'd say B squared equals A squared plus C squared minus 2AC cosine B. I'm not going to write all the forms because we wrote them yesterday. Okay, and so when we're looking for a side measure, notice that we have a side squared over here. This is the formula that we would use. So we would use this form of the formula, which is the original form of the formula if we're looking for a side. If we're looking for an angle though, which in this case we're given all the sides and we want the angles, so we could rearrange this equation. So let's say I had all the sides, A, B, and C, and I wanted to solve for angle C. So what you could do is modify this equation here, this formula here, so that you could isolate the cosine of angle C. So quickly to do that, what I would do is just take this whole quantity and add it over here and then subtract the C squared and put it over there. So I'm going to add this and subtract that. So it would look like this, and I'm going to get a different color here. So when we're looking for angles, if I wanted, I didn't want that color. Let me get it this color. So 2AB cosine C, that's me adding this to the other side, is equal to a squared plus b squared, which is I didn't move, and then I'm going to subtract the c squared over here. And of course you could do that by hand using your algebra skills. Okay, so remember what I'm wanting to do. I'm wanting to isolate cosine of c. So now I would just divide by 2ab, divide by 2ab, and I would get the cosine of c is equal to this modified formula for the law of cosines. And that's okay if you put these things on your index cards and your references. Now, let's say I was looking for angle B then. Here's what I want you to notice. Here's we have side A, side B, side C. So we're subtracting, see the C here and the C here. So the two sides that we have are being added, and the side that's opposite the angle is being subtracted. And then the A and the B go down here in 2AB. So if we were to do cosine B, then we would want the two sides that are not opposite. So that would be a squared plus c squared, and then minus b squared, because that'll be the side opposite the angle. So you're subtracting the side opposite the angle. And then it'd be over 2 times a times c. Or if we were doing cosine of a, we'd want to be subtracting a squared. So we'd want b squared plus c squared over 2 times b times c. Okay, so those are the formulas. And this is if you're solving for an angle. This is just an easier form than plugging in all the values for a and b and c and a and b, and then simplifying all that and then isolating cosine c. It's just easier to modify the formula. Okay, so here we have example 3. Solve triangle ABC if A equals 3.5, B equals 4.7, and C equals 2.8. Okay, so I'm going to draw a triangle with sides 28, 35, and 47. I'm just getting rid of the decimals while I'm thinking here. So 28 would be maybe that long. 35, let's see, would be like maybe that long. And 47 would be like maybe that long. Okay, so this would be 2.8, side C. So this would be angle C up here. And then this would be 3.5, so that would be side A. So that would be angle A over there. And then this will be 4.7, which is side B. And so this would be angle B over here. And let me just double check that. C is 2.8. A is 3.5, B is, okay, all right. And so definitely here we have side, side, side. So I always like to tell you guys, well, when you're using the law of cosines, it really doesn't matter which angle you start on, but I always just like to start on, when I have side, 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 I always start on the smallest angle. That's just what I do, but it doesn't matter with the law of cosines. Let's see. So I'm going to go ahead and find angle C. So remember that we're looking for angle C. So I'm using the modified version. So that is not a C. Let's try that again. Cosine of C is equal to, remember that we're subtracting C squared. So that would be a squared plus b squared minus c squared over 2 times a times b. All right, so now I'm going to substitute those values in. So the cosine of c is equal to a squared, so 3.5 squared, plus b squared, which is 4.7 squared, minus c squared, 2.8 squared, all over 2 times 3.5 times 4.7. And if you wanted to, you could plug that into your calculator first. I am like trying to save myself pressing buttons into my calculator. So I'm trying to find the measure of angle C. So what I typically will do is not simplify this. I'll just take the cosine inverse to get rid of cosine on this side. Take the inverse function to undo the function here. So I would say C is equal to the cosine inverse. And I would plug in all of this information right here. And that way I just have to use my calculator once. So I'm going to put my calculator here. Make sure I'm in degrees. I'm in degrees here. So I'm going to go ahead and go cosine inverse and then get my fraction here. And type in 3.5 squared plus 4.7 squared minus 0.8 squared all over 2 times 3.5 times 4.7. And you don't even have to close the parentheses, but we will anyway. And here's what we get. 36.344222106 degrees. So that gives us C is approximately, let's bring that up one more time, 36.34 degrees. And it's okay to go ahead and go with degrees just to the nearest tenth of a degree in this case. And so there's the value for angle C. We now know that it is 36.3 degrees. Okay, and so your job now is to find angle A and angle B. And notice now what we have is side angle side. We have side C and angle C here. So we could now switch to the law of sines to find angle A or angle B. It's up to you. Or you could switch, can just stick with the law of cosines if you want. So I'm going to pause the video here and I'm going to let's all go with finding angle A. Let's decide that we're all going to find angle A. So you can find angle A with the law of sines or the law of cosines, up to you. So press pause and solve for angle A. Okay, so in this first example, I used the law of cosines again to find angle A. So, I'm subtracting side A over here, adding side B and C squared, and then dividing, and then taking the cosine inverse of those values, and I got 47.8. Or I could have used the law of sines. You could have used the law of sines here, where we did this sine of angle A over side A, 3.5 equals the sine of 36.3 over 2.8. Cross multiply, take sine inverse, and you also get 47.8. So either of those methods would work. It's just what you want to do. All right, so now we found angle A, which is 47.8. And so the only part of the triangle that we have left to find is angle B. And I always save the largest angle for the last step. That's just me. Especially when you're using law of cosine or law of sines, you need to be cognizant of that. Let's see. So angle B here, we could just use, I don't know anybody that would use the law of cosines or the law of sines here unless they were just trying to be fancy, would use the angle sum theorem. So I will use angle sum theorem to find angle B, which will just be 180 minus 36.3 minus 47.8. And you've seen me do this multiple times. Just not plug that into the calculator because I have the answer here, and I'm plugging it in, and it is 95.9 degrees. And so now we have solved that triangle. So I'm going to go back with my highlighter here. Here's angle C, here's angle A, and here is angle B. Okay, so that's done. So that's that, using side, 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 and using your options. Okay, last problem. Here we go. So here we have example 3 circles, and it says 3 circles are arranged as shown in the figure to the right. You can see that they're all tangent to each other. These circles are touching each other in one spot. And it says find the measure of angle Q to the nearest tenth of a degree. Now, if we look at all these circles here, they all have radius. Okay, so I know that this is a radius. Let me back that up and grab my pencil here. I'll get back here. I did not want that. Sorry about that. All right, so I know that this is the radius because this is circle P. Circles are always named by their center point. So this would be circle P, this is circle R, and this is circle Q. So these are definitely the radii. And so we're looking for an angle, and it looks like if I add 33, this radius here, and 38, this radius here from the center to the edge, I could get side P here. And then if I take these two radii here, which is 23 centimeters, and this radii here at 38 centimeters, and add those together, that would give me side R. And then over here, of course, from P to R, which would be side Q, we would add 23 plus 33. So I think I'll just do that over here. I'll just draw another picture here. So 23 plus 33, I'm just going to add those together. That's 56 centimeters. And this is going to be side Q, and this is angle Q, which is our focus here. We're trying to find that measure. Okay, 38 plus 23 is 71 centimeters, so that's going to be angle P there. And so this is going to be side R. And then this bottom one here, that is not 71, that is 61. Let's try that again. That is 61 centimeters. Okay, and then Q to R is 38 plus 33, so it's 11. Carry the one, that's 71 centimeters. I had it backwards. Okay, so that is side P. So we have this triangle here using the radii here. So we have side, 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 and we're looking for angle Q. So we're going to go, okay, since we're looking for an angle, we're going to use the modified, we're not going to do angle A though. Let's try that again, the cosine of angle Q. We're going to use the modified law of cosines here because we have, that is not a C, law of cosines, because we have side, side, side. All right, so we're going to go, so we want to subtract Q squared, which means we want to add P squared plus R squared, and then over 2 times P times R. So we're going to plug that information in. So the cosine of Q is equal to P, which is 71, squared plus R, which is over here, 61 squared, minus Q squared, which is 56 squared, all over 2 times P, which is 71, times R, which is 61. Okay, and so now we're just going to take the cosine inverse to isolate Q. So Q is equal to the cosine inverse of this value right here, all of that. So we'll plug that into the calculator. Turn it on, make sure we're in degrees still. Okay, so we want cosine inverse. And we want a fraction here, so we can type this in. 71 squared plus 61 minus 56 squared, excuse me, all over 2 times 71 times 61. Double checking here that I typed it incorrectly. Hit enter, and we get Q is equal to, what was it? 49.495. So I could say approximately, and it says to the nearest tenth. So let's get that, go back and look at that to the nearest tenth of the degree. That would be 49.5 degrees. And that's all we were asked to do. And so we are done with that one. Okay, and so that's the lesson for today. There's an assignment on Canvas, 11.2b. I think it was 1 through 6 or 1 through 7. I can't remember exactly, but this week's assignment, what you're doing is you're entering things. You'll do the math on your paper and then enter your answers into Canvas. And you do have to enter them carefully and exactly, or you'll get the answer wrong. So make sure you're paying attention. If I say round to the nearest degree, or round to the nearest integer, or round to the nearest tenth, pay attention to that. Okay, there's your lesson for today.